let me let you know what the answer for letter B, if you've got one. So check that with me. So it's the summation of 1 over 3 to the I minus 1 power. Since you see that it's n minus 1, right? But you're running the I from I equals 1 to n. So what you want to do is you can always come up with any kind of educated guess. So some people might put 3 to the I, right? Or something else. But what you want to do is check the summation notation, right, by looking to the first and the last term. Now, of course, I'm not saying that if the notation works out for the first and last term, it has to be 100% correct. But it's almost unlikely that you get it wrong. Try I equal to 1. Right, so it's 1 minus 1, so it'll be 0. 3 to the 0's power is 1. So it does get you the first term. See that? Now, the last term, I becomes n. It is 1 over 3 to the n minus 1. Right, so that's indeed the last term. Right. Now, I think that I already asked you, maybe I didn't. So how many terms do you think that are there added up in letter B? How many? Now, is it n or n minus 1? It's n, right? So now, in this case, it might not be that tricky since I literally showed you, right, from 1 to n. But what if, so I rewrite letter B as 1 plus 1/3 plus 1/9 plus ... 3 to the 9th power. Forget about you have figured out what the generic term look like. If I'm asking you how many terms are there adding up in the sequence, would you go with 9 or 10? 10. So the question is, how would you alert yourself that a lot of people might go with 9? Do you see that? And it matters when you have to seriously add up those terms, right? And you know what? Most likely, there will be an option like that, right? It'll be 9 terms, 10 terms, 11 terms. Almost always, students want to make a mistake, they off by a term. Either they overcount a term or they miscount a term, right? So again, just bring it up to let you know that later on, when you're counting the number of terms adding up, be careful with exactly how many terms you're adding, okay? Now, so these properties about summation, seems complicated just because they were written in such a fancy form, but they're not. Well, I guess that there's not a razor. Better not to use too much board. But it turns out that you already know them. For example, right? So let's not get into those details of the rules, right? The properties. So let me show you something that you probably already know very well. So I have 2 sequences. The first one goes like 1 and a 2, 3, right? So I want to add them up. And then I have another sequence that goes like 9, 8, 7. Typically the sequence has infinite many terms, right? But in this case, just to see what's going on, right? Let's just make our life a little easier. Both sequences have only 3 terms. So when you add them up, am I allowed to add 1 and a 9, and then 2 and an 8, 3 and a 7? Oops. So first up, I add up the corresponding pair, right? Then add them up. Is that okay? Now, what was the property that we have used to change the order of addition. Instead of adding up those three numbers, I actually add up the 1 and 9 first, right? Then 2 and 8 and 3 and 7. What's the name of the property of addition? Oh, go ahead. Commutative. That's about like a swapping things, right? That's actually what we call associative property. That means you can associate 1 and a 9, put them together, the order doesn't matter, right? So, well, not to say order doesn't matter. It doesn't matter if you add up those two first. So now let's see, why am I talking about the associative property? Take a look at the last property here. Do you see what's going on? Let's see if you look on the right-hand side. It's asking to add up the first sequence. Then you have the second sequence added up, right? Later, you add up the sum of the two sequences. But it's the same thing as you add up the corresponding terms, 1 and 9, 2 and 8, 3 and 7, right? It's protected by the associative property. Or superficially, you see that you get to separate the sum within the summation. So adding up individual sequences is the same thing as add up the terms, later sum them up. So if you find that useful sometimes. Okay. Now to see the property right up of the associative property. So again, now I can think of now that's the first example. All right. So the second example. So again, let's say we have 5 times 1 plus 5 times 2 plus 5 times 3, right? So this is like that I have a sequence which only has 3 terms, but every term has a constant a multiplying that term. Here the constant is 5, right? So I add them up, but can't you simply just factor out of 5 and add up the sequence 1, 2, 3? No, that's exactly what they said on the other side. Factor out of 5, right? Factor the constant, right? Sum over the sequence, then take the common factor. So again, where now you added the sequence, then multiply the factor, or multiply every single term by the factor, then sum them over, it's the same. Okay. And now guess what? If you combine the oh, by the way, so the name of the property in this conclusion is called the distributive property. Right? So you distribute a 5 or factor it out. So when you put these two together, right, you get this fancy form. Right? That means the sum has distributive and associative property. Right? That means you can take any sum, break it up, right, into individual sums, right? And also you have maybe a common factor multiplying a generic term. You can take that out of the summation, get the summation done on those simple generic terms, and do the sum, multiply the common factor later. Okay. It's not very often that you have to use in our course, not even calculus, but I guess that you're probably going to see this kind of summation properties maybe in the later half of Cal 2, right? When they talk about infinite series and stuff. So therefore, I just want to mention that this is something that you might want to think about, but not that important, then or at least they're not as important as factorial, right? Summation notations and stuff like that. All right, so I think that's a good time to take a break of 10 minutes. Right, when you come back, we'll go over 11.2.
You know, Santiago was like, that's not even what what? Chihuahua. That's not a word. You know what I'm talking about? Okay, thank you. And chingada.
He slipped in. That's but the thing is too like he just this one you gotta choose all friends. You I don't know about That's funny. This one is nice. I remember.
Yeah, I know. They look really nice. They used to look really nice. No, so right. No,
I didn't know what color to read.
It's like blue.
Yo, she got me. Into my calculator. You're fucking there. Yeah, sure. Excuse me. It's like Josh already. Oh, that's fine. It's like, or the tricks. This was funny. Right there.
You see that one?
Trick is terrible. Wait, so it has to be C. And you're doing my.
Oh, I saw the never so
All right. Testing, testing. All right, guys, let's get started. All right, so 11.2, that will be on the quiz tomorrow. But I guess that things like geometric or arithmetic sequences were covered in Algebra 2. Because I taught, year Algebra 2 at my older school. So I kind of remember we did something like that. So it's more like a refresh. Now, starting from how we define the arithmetic sequence. So I'll say that maybe just take a look at an example like a sequence that starts from 5, right? Then the next term will be 7, then 9, 11. So it seems that you're just adding a constant, right, every time to go from a term to the next one. Now, we do have something called a common difference, right, to capture that kind of a behavior. Because, if you're always going to add a constant to go from a term to the next one, don't you think that the difference between two consecutive terms will always be a constant, right? And we just call it common difference. Okay, so that's something you must have for a arithmetic sequence. So for the example here, the common difference is 2. But the catch is, this is exactly how you define the common difference, by subtracting two terms. And the order has to be the term, let's say a sub n, minus its preceding term. Okay, so that means that, yes, the difference is 2 or negative 2. It depends on if you're always going to subtract the term after it, right? Or, you go before, that term. But let's put it this way. The convention is you always subtract, say, a sub 1 from a sub 2, right? You always subtract from, you always subtract a sub 2 from a sub 3, right? So that will be the common difference that everybody's talking about. So that definition of a common difference quickly turned into the recursion formula for the arithmetic sequence. And it actually does make sense, right? Since we always add, right? Later on, you could subtract, but most likely add, right? A common difference to a term to get to its next term. Okay. Now, the example you saw over here is more like a SAT kind of style question. So it does require some knowledge of the arithmetic sequence, right? But it's not as traditional as those questions we have in the book. So let's just take a look, right? So we have 3 consecutive terms in the arithmetic sequence. The middle term was given, but the term before it will be 2x, right? And then the term after that will be 6 minus x. And obviously what bothers people is what x is. But not giving you x, they still want to find out what the common difference, that little d. But it turns out that you could just impose the definition of the common difference, right? Since it's common difference, why don't you subtract, right? Let's say this first term, you can call it a sub 1, right? Not a big problem. A sub 2, right? A sub 3. So if you subtract a sub 1 from a sub 2, right, which is 5 minus 2x, you should get the same exact difference, right? If you subtract a sub 2 from a sub 3, right? So a sub 3 will be 6 minus x, then subtract the 5. So that way, set them equal. So you're demanding that x has to take whatever number to make it work. And it turns out that you're solving for the x from that linear equation. X turns out to be 4. And once you get x, so you can reconstruct the sequence, because now the first term is simply 8, right? Middle term is still 5, and the third term will be 2, right? Now you see that it actually does go down, right, instead of growing. No wonder that the common difference, if you work out by subtracting a sub 1 from a sub 2, it will be negative. So it is perfectly fine to have a negative common difference. So that means instead of adding, you are actually subtracting the 3, right? Subtracting a constant from the term to get the next one, right? So you can have a growing common, arithmetic sequence like the one you saw over there, 5, 7, 9, 11, right? Growing with a positive common difference, or a decaying sequence with a negative common difference. Okay. All right. So now moving on. Now, as always, we'll look into the general formula for the nth term, right? Just to make the description of the sequence a bit easier, because the first thing that comes to your mind when you study the sequence is you want to know every single term, right? So you need to have a tool to tell you whatever term you want, right? Whenever you want. And it turns out that it's as easy as thinking about how would you get to every single term in a sequence. If the pattern is you start from, say, a sub 1, you're always going to add a common difference, right, to get, let's say, a sub 2, then add another one to get a sub 3, and so forth, right? So now the question is, if I want to get a sub 10, you're going to start from a sub 1. So how many times the common difference do you have to add to a sub 1 to get a sub 10? 9 times. Or how do we know that it's not 10 times? So that means don't overcount it, right? And like I said, it's just about counting the number of terms you're adding up, like you saw before. So always be careful with however many terms you have to take, look into, or however many common difference you have to add, right? Or later on for the geometric series, how many times of the common ratio you have to multiply, right? And then somehow it's a bit counterintuitive because it has the 10 there. So make sure that you are taking the difference between let's say the final value of the n and the starting value, right? So these two index, right? Subtract them, you get the difference between these number, and that's how many times the common difference you have to add to the a sub 1. Because remember that if you add 1d to the a sub 1, you get a2 already. It's not going to get you a sub 1. Therefore, you don't need to add 10d. It's only 9d to get you from 1 a sub 1 to a sub 10. But later on, there's no point of keep doing this kind of reasoning, right? Just remember that the formula takes the form of a sub 1 plus n minus 1, since n is eventually what you want to get, right? The nth term. So it will be the difference between these two indices times the common difference. Okay. But it turns out that we don't necessarily always start from a sub 1, right? And it turns out that you can start from anywhere in a sequence. You can also end anywhere. So here, the second version is more general, right? And obviously more powerful because it allows you the freedom, right, to start from anywhere. So let's say a sub m, where m could be any integer. Doesn't have to be 1, okay, as you will see later in an example. And also remember that since I didn't say y, or I didn't specify, if n must be less than n. So you can actually start from somewhere later in a sequence and go all the way back, right? As you will see later in an example, okay? But the pattern you notice that you saw, right, from the first version is that you always take the difference in the two indices, and that is the times of the d that you're adding to the starting point, okay? Now let's give it a try. Say letter A, start from a sub 1, right? We know the common difference d. What is the 16th term? So by 16th term, I mean it's a sub 16. So I guess that we could just go with the first version of the nth term formula. So take n to be 16. A sub 16 is a sub 1 plus, now it's 16 minus 1, right, times the common distance d, right? That will be negative 12 plus 15 times 4, right? So you're going to get 48. Right, so that's it. All right, so that's pretty straightforward. Now, letter B, you're given a sub 8, right? The eighth term, and the difference, common difference D is negative. That means it's a decaying sequence, right? But you want to find the third term, which is a sub 3. So I want you to actually think about using the second formula, right? So you can start anywhere, right? So in this case, let's say since I know what a sub 8 is, right? Can I just start from, oh, you know what? Let me put this down. A sub n is a sub m plus n minus m d. So in this problem, why don't you take n to be whatever term you want, right? So it will be the third term. So n is 3, right? The starting point, let's take m to be 8. And the difference, the common difference is negative 7. Therefore, a sub 3 is a sub 8 plus 3 minus 8 times negative 7. Oh, I should have put in the actual value for a sub 8, right? So that's 24. All right, so that will be, what is that? 59. So now, if somehow you're such a big fan of the first version, that you feel like that you always want to start from a sub 1, you could start from maybe a sub 8, go backwards, right, to find out what the a sub 1 is, then go to a sub 3, right? You can try it, but it's not recommended, right? Because why would you take a detour? If you're going to get a sub 3, you already know what the starting point is, right? So as if that this is like, so say that you want to take, you want to go to library, right? But you know that, maybe after 2 hours of learning math that you might feel sleepy, that you might have to take a nap, right? So instead of going to a library and maybe finding maybe some cozy spot to maybe take a quick nap, you say, let me go home, right? I'll take a nap for about 20 minutes, then I'll come back, because eventually you want to go into the library. But why would you do that, right? Go there, right? Let's say if you drive, on your own in the morning, you know that our morning class starts a bit early, right? So if you still want to take a nap, maybe go find a good spot in a parking garage, right? When there's some breeze, right? So you can maybe take a nap for 10, 15 minutes, right? Why would you stay home and take that nap and end up being running late, right? So I'll say that go straight to the ultimate thing you want. Not to mention, you have a formula to do it, which is the second version. And don't see second version is anything different from the first one. It's the same thing, it's just more powerful, right? Because if you take m to be 1, the second formula reduced to the first one, right? So remember for the second one, that if you do need the first one that starts from a sub 1, you can always do it. Now, let's take a look at letter C. So I guess that there might be some confusion about what explicit formula is. So that was from the old version of a textbook, and they did say something about explicit formula, but that's nothing but a sub n. Okay, so it needs to be explicit formula about the n, so then it's ready to go. So basically, it's just asking you to find out what a sub n is, given no common difference. All we know that it is arithmetic. Let's start from a sub 16, right? And you have, a sub 30, right? Those two terms take from the sequence. So now let's say if, again, you're such a big fan of, the first formula that I showed you, the a sub 1 plus n minus 1 times the d, right? So you need to find out what a sub 1 is, right? And also what the d is. But let's focus on what the common difference at this point. The So it turns out that we might end up using the second formula anyway, right? Since I have the 16th and the 30th term. So let's say if I go with a sub 30, but I start from a sub 16, I need to add 14, right, which is 30 minus 16 times the common difference, right, to go from 16 to the 30th. Yep. Oh, yeah, thank you. I was thinking about the... Yeah, so you actually get 14 by subtracting 16. All right. So now if you want to solve for the d, just by taking the difference of a sub 30th, a sub 16, right, divided by how many terms are they apart from each other, right, which is 30 minus 16, right? Therefore, you get 203 minus 105 over 14, right? So what do you get for the common difference? Okay, 7. All right, so once you have the common difference, I mean, again, you could find out what a sub 1 is, right, by going backwards, since you already know what a sub 16 is, right? Plug it into the first formula and find out what the a sub 1 is. But why would you have to do that if you could have started from a sub 16, right, or a sub 30th? So how about we start from a sub 16? So a sub n is a sub 16 plus n minus 16, right, times the common difference d, right? So what a sub 16 is 105 plus n minus 16 times the common difference 7. Okay. Now, of course, you know, if you leave it like that, it's not wrong, but it's just not very conventional. So if you could, please simplify this by distributing the 7, right? And you end up getting 7n minus 7. All I did is just distribute the 7, right? It gets multiplied with negative 16, so you get 112, right? Then you subtract that from 105, you get negative 7. Right? And this is what they mean by explicit formula. You see why they call it explicit, because it only depends on n. So if you want a particular term, let's say a sub 100, just plug in 100 for the n, you get it, right? And that's but you know, of course, you know, if you see something from you know, our quiz or test that the terminology wasn't you know, used in you know, in class before, then please let us know, because it might be because the question bank is not really that perfectly lined up with textbook, since you know, textbooks always having different versions, but as they update a version of a textbook, they may not update all the questions in the question bank. Okay. But anyway, so that's yeah. Oh yeah, go ahead. No, and that's actually a good check. You know, if you start from a sub 30, right, then you would have put a sub 30, 30 minus 16 times the d, which is still 7, you get the same thing, right? And that's why, since everywhere from the sequence could be a starting point, right? You can also end anywhere, so don't restrict yourself to always a sub 1, right? And you see that we could even go backwards. You see what we did in letter B, right? Don't feel like you're always from, you know, a term, right, to like the later term. You can go either way, right? And that's how powerful those formulas are, right? It just tells you how to locate a certain term. All right, anyway. Any questions before I move on to the sum of the arithmetic sequence? All right. Now, for arithmetic sequence, since the pattern is actually a lot more intuitive than many other sequences you end up dealing with in the future, So what really makes it interesting is we also have a surprisingly powerful formula to add up however many terms in the arithmetic sequence. All you have to do is getting however many terms, right, and know where the sequence starts and we'll know where it ends. So let's say, so we're trying to add up all the numbers from 1 to 99, not missing any number, right? So go from 1 to 99, add them up. So as you see that has to be a arithmetic sequence, right? So then what is the common difference for this particular sequence? The common difference is 1, right? Okay. Now it turns out that there was this guy a couple hundred years ago figured that this is actually a much easier way to add things up, however many terms you have, right, if they show up a pattern like an arithmetic sequence. All right, so this is what this guy did. So they say what he said. Now, I don't know what the sum for that many terms is, but you can rewrite the sum backwards. So from 99 down to 98, right, to 97, all the way to 1, right? So those two sums are the same. And he said, now why don't you just add them up? But you add them up pairs. See, the first pair, 1 plus 99 is 100, right? The same thing for 2 plus 98. And it turns out that this works out for all the remaining pairs. So the question is, how many 100 we're adding up? What do you think? 99. Because there were 99 terms, right, in the original sequence. So there are 99 of them. Okay, so now we're getting 99 times 100, right? Is that the sum we want in the first place? Almost, right? Not quite exactly, since it's twice as much of what you want, right? So now all you have to do is just divide out the 2. And you get, what is that, 4950. And guess who that guy was? Well, how many mathematicians do you know? The famous one. Pythagoras. Oh, that's a bit too old. Yeah, I think that this guy is like some couple hundred years BC, right? Not before. It's like that's how old this guy is. You know, it's a Greek guy. Yeah, what else do you know? Say again? Aristotle. Okay. You guys are a big fan of those really, really old people. Say again? Yeah, he's a mathematician and a physicist, but not Newton. It's a German physicist. No, German mathematician. His name is Gauss. Gauss. Well, you guys know Euler? Have you heard of Euler? So those two are the two famous geniuses in math. You know, mathematicians call them genius. That means they don't have to learn, they just figure it out, right? And I think that one of those guys is called the prince of mathematics. I don't know if it's Gauss or Euler, maybe Gauss, because this guy's more romantic in a way of he doing things. So what happens is this guy figured out in elementary school. So I guess that he was bored in a class and the teacher figured out, you know what, let me challenge this kid, right? The teacher came up with the problem. Go ahead, add up from 1 to 99. And he figured out this way. Of course, he wasn't the first one who came up with the way, but he just figured out. Maybe he just see how the pattern goes, right? And you know that's the difference between a mathematician and a scientist. So a lot of mathematicians are just born to be smart, right? So they just figure it out. But at least that thanks to this guy, right? you know, sometimes, you know, people like to call this formula the Gauss's formula. But for those who have done statistics, well, have you done statistics already? Like I said, you probably have, well, you don't have to, but, you know, if you want to have your option open, maybe you will choose a semester to do stats, right? There's something very famous called Gaussian distribution. You probably haven't heard it that way, but what about normal distribution? Bell-shaped curve. Who invented it? Gauss. So this guy knows pretty much everything in math, right? And guess the year he was in, it's like the 18th century. So a couple hundred years ago, so they already figured these out, right? Anyway, but now if you take a look at this formula that we just came up with, right? Or we didn't came up with, right? So this guy came up with. So do you see how powerful it is? It only needs the number of terms you're adding, right, which is n, sum of the first and the last term. So you know where to start, right, with the n, and just divide that too. Okay, and I believe that you know, most people is going to go with that. But the problem is sometimes, you know, yes, it is also maybe the one I'm going to go to for the most of the time. But you also need to you know, have your option open to cases when they don't have the last term. Or maybe it's not worth the time to look into the last term, even though it's, you know, something you could figure it out. So what they did is they say, look, that's the nth term formula, right? Which depends on a sub 1 and you know, number of terms and the common difference. And it turns out that whichever formula you use, either the Gauss one, right, or the one we're gonna have, you know, as a second version, they both require your knowledge of a sub 1. You're gonna have to know where you start. But instead of having the last term, you're going to substitute this guy, right, into the a sub n. But it does make the formula a lot more ugly, right? So you have the 1/2, right, n times n minus 1 times the d. Honestly, if I don't have to teach it, you know, if you ask me like right away, I probably gonna remember the Gauss's formula, right, not this one. Or you know what, I'm most likely gonna miss that 1/2, right? Maybe I was thinking about, is it n plus 1 or n minus 1? Right? Well, maybe I didn't realize there's an n minus 1 there, right? But at least that in our quiz, you have the packet, right? So, but you should open to using this one sometimes, okay? But nothing wrong with the Gauss formula if you're always a big fan of knowing the first and last term, right? So now let's try letter A. Let's find out the sum of the first 100 terms in the sequence. But first, why don't you think about what kind of a sequence is that, right? First up, is it arithmetic? Even though they say that, right? Is it? It's basically odd numbers, right? So yes, right? So for such a you know, arithmetic sequence, the common difference is 2, right? Now the question is, what is the last term, right? I know that you guys want to use the Gauss's formula. So now the question is, hey, we know a sub 1, which is 1. What is a sub 100? What do you think? By following the pattern, right? Skipping the even number, you start from 1 all the way to the 100th term in this sequence. What number are you going to hit? It better be an odd number. Good. It's either 100. Because how many odd numbers are there in a number from 1 to 100? How many odd numbers? 50. That means if you count 50 odd numbers, you're going to go from 1 all the way to 99. So 99 is the 50th odd number. But I need another 50. I'm going to start from 101 to 199. So, but you know, a lot of people will think, oh, is it 200? But then wait a second, 200 is not an odd number, right? Is it 201? Is it 109? Oh, was it 199, 197, right? That's why it's kind of hard to be sure, especially in a test. So now that's the question I'm asking you. Is it worth looking to the last term? No, right? So what if you don't have it do we have everything to work out the sum of the first term, first 100 terms? If you were to use the second version of the formula, you need the first term. We do have it. We know there has to be 100 terms to be added up, right? The common difference too. You have everything, right? Let's go with the second version, right? So it'll be S sub 100. Now that tells people that you're adding up the first 100 terms, right? The first term is, the number of terms is 100 times the first term, which is 1 plus 1/2 times, and which is 100 times 100 minus 1 times 2, and you work it out, it's 10,000. Okay. But of course, if you still want to use the Gauss formula, you're gonna have to figure out a sub 100 is 199. And you plug into the Gauss formula. Let's scroll down a little bit. It will work out, right? Take the n to be 100. A sub 1 is 1. A sub 100 is 199. Divide by 2. You're still gonna get 10,000. Okay, but again, please make sure that it's not worth to get yourself a sub 100 just because you want to use Gauss' formula, because you want to be practical, right? Whichever gets you the quickest, right, the accurate answer will be the method you want to go for. All right, now, what if I wanted to figure out letter B? Now, of course, I use that summation notation at this point it's supposed to be arithmetic, right? But if that's in a test, right, you have much better way to figure it out, right? So why don't you guys try that in a calculator? Type it up, right? I mean, that's the way to go for most of the time, right? But we'll actually figure out the algebra in a second. Remember that you're gonna have those questions on the quiz tomorrow. Make sure you have your calculator ready. Not just ready, you need to know how to use it and make it quick. All right, that's what I'm asking you. All right, anyone got the answer from the calculator? How much is the sum? What do you guys get? 1,400, yes. All right, so now let's say if it's in a test, that could be very likely FRQ, right? So now you know that, get the right answer reliably from the calculator to make sure at least that you have the right answer, right? But then you have to show me the work, right? So typically, so my FRQ in a test will worth 5 points. So you don't have any work, but you get the answer right, you don't get 5 points. You have to show me the work. So if you do get the work reasonably out there, but if you get, instead of 1,400, something close, right? So I'll take a point off, all right? So that's how you grade your work. But why would you miss the answer if it's so easy, right? You could, go straight from the calculator, right? Get the answer right. But of course, multiple choices, you don't get any partial credits for the work, right? Just make sure you get it right. Now, but the correct way, or algebraically, right, how would you work it out if it's FRQ? So hopefully you realize that it's arithmetic with a generic term in a form of pi by minus 9. But is there a way we can check to see if the sequence is indeed arithmetic? Plug in two numbers, right? But that's basically just, maybe checking to see if you get something super raw, right? But it's not safe enough to prove it. but checking to see if you do get a common difference. I mean, plugging two numbers is good enough, right? So if you want, take maybe a sub 1, right? That'll be 5 minus 9, will be -4, right? And a sub 2, that is 10 minus 9, right? So you get you get 1, right? So now, you know what? Just to be safe, I'll do 3 terms, right? So that'll be 15 minus 9, so that's 6, right? You do see that it has been going up by 5 units every time, right? That seems arithmetic. You know what? Those work not going to be wasted. So now, would you say that, how about we try the Gauss's formula if it's arithmetic, right? Because we're, a sub 1, right? So what do you think will be a sub 25? Because you're going to add up 25 terms. How would you get it? It's 25. If the generic term is right there. So you just feed 25 to the I, right? It'll be 5 times 25 minus 9. So that's 116. All right, so now you have everything, right? So the first 25 terms will add up to, the number of terms is 25. The first term is -4. The last term will be 116, right? Divide by 2. You're going to get 1400, right? So they must be consistent. Oops, sorry. All right. Any questions so far? All right. Well, it looks at that, we do have a few minutes left. Let me get you maybe a challenge question. See how much beyond the level of the course you can. Again, no pressure, but don't ask for extra credits. All right. So it's something that you just want to challenge yourself, because I think that you're old enough, right, not to work only on those little treats or even extra credits.
That was very too bad.
Let's see, where did I put it? You probably need a partner, or if you want to ask around, right? All right. Go ahead. Now those x and y are the index, right, to track which term you're looking at. Now, just to make sure that you guys understand what I'm asking for, right? Any volunteer for the month and the date to share with us? Yeah, go ahead. So that will be 3, right? March what? 23rd, 25th. Okay. Oops, sorry. All right, so that will be 25th, right? But 25 gets squared. Okay. Now I need one more. Lucia. All right, so then it will be October. Okay. So I'm still thinking about in Chinese. What's October? So it's 10 October 3rd. Okay. Right. So basically, so the x will be what's the name again? What's the name? Giada. All right. So let's say x is the month, the birth month of Giada's square. Right. So x will be 3 square. Right. So what about y? Will be Lucia's birth month square. So it'll be 10 squared, right? So that will be 9. That will be 100, right? So what's a sub x? A sub x will be 3 minus 10, right? Which is negative 7. A sub y will be 25, will be 625 minus 9. What is that? 16, right? So now you have two terms, right? Which says a sub 9 is negative 7. A sub 100 is 16. So you need to find out what the common difference and also what's the first 109 term, the sum of the first 109 terms, right? So that's what you could do, right? You have 5 minutes to. No, I'm not saying that. You have 5 minutes before you can leave. But that's just an example. And the number is not going to be integers, most likely, right? So it'll be kind of ugly decimals. As long as you know how to do it. If you have an answer, come by. I have something to check your answer. All right, if any group has the answer, come to me. I'll check that for you. It's gonna be hard to find the common difference. It's just not an integer. But you need to find the first that many terms, right? And what happened in the past is people are not starting from a sub 1. You need to always start from the first term, right? Because the first, let's say in this case, first 109 terms, it should be starting from a sub 1, ends at a sub 109. And people might start from somewhere in the middle. Anyway. All right. Anyway, so since I'm still here until 4, if you want to come by and talk to me about that problem, if you have an answer, feel free to come by, right? But again, just to make sure that everyone should start 11.2, right? And also bring your calculator, the scientific calculator that works with factorial and summation notation. Have your laptop ready. So with or without lockdown browser, I think that most likely to do the quiz tomorrow on D2R, right? Just so you know, you have access to your notes and a packet, and also the time is going to be issued. So 10 minutes for 5 multiple choice questions, right? Yes, TID4. No, it doesn't worth any extra credits. It's just for you to feel, just for fun, right? See that? I wish I heard that you guys, Dr. I don't get extra credits. We just figure it out because we get this. Right? Yeah.